Hey guys! Oh man, do I miss you? I know, hard to believe, right? Okay, well, anyway, wanted to give you updates or some announcements. Make sure that you remember that the rules still apply with Miss Ayada. Continue to be respectful like you've been. Heard no issues arose this time. Good. Field trip. Bring your money Thursday, Friday, and we will receive that for our field trip. Test. You do have a test this week. You have a test on Friday, so get ready for that. We will go over the, what do you call it, study guide. We'll go over the study guide when I get back. Second period, please remember to have your video permission slips in. We will need those tomorrow. We're videoing tomorrow. I don't want to have to find another place for you to go do book work. So let's get that signed and turned in. Mrs. Adon may have extra copies up at the front of the room, but if not, don't know what to tell you. Explore Day is going to suck for you. So let's make sure we get those slips turned in, okay? All right, well, that is it. Can't wait to see you guys and be with you for a little bit before I have to leave again. So keep up the good work. Study hard. Get your notes done. Watch your videos. Do your PowerPoints. Okay? All right, guys. So today we're going to be talking about water quality. Make sure that you have copied the slides and that you have answered any questions that go along with the slides. As you look through this presentation, please feel free at the end to let me know if you have any questions at any point. So you are well aware that there are different types of pollution, and water pollution is one of them. But what you may not know is there are two different types of water pollution. One of them is point source pollution, and the other one is non-point source pollution. So when you have point source pollution, that means you can tell exactly where it happened. Okay, it came from a smokestack. It came from a car tailpipe. It came directly from someone dumping something in the water that you could see. So that is an example of we know who did it, we know where it happened, so we can point out the source. Now, with non-point source pollution, it says the contaminant source cannot be found. And that means you don't know who did it. So, for example, that they give is if there's farmlands and say that there are 10 farmers in the land. Looking down the way, there's pollution in the water in the local creek. Well, if there's 10 farmers, how do you know which one did it? So that is your non-point source pollution. So when we're looking at those major sources of water pollution, whether point or non-point. So we know agriculture is one of our non-source point pollution. Sorry, that's a mouthful when you have to say it over and over. So agriculture being the main one is because mainly of that traditional type farming that we use. And that traditional farming adds pesticides and fertilizers to protect the crops. And we have talked about how irrigation works and how over irrigation can start runoff. So all that is not filtering into the ground or the plants it's supposed to protect. Some of it gets runs off into streams and lakes and rivers. So there's other bodies of water, that surface water that we have, for example, that water on the surface. Keep that in mind. Groundwater is in the ground. Surface water is on the surface. So that runoff is carrying along those pesticides and fertilizers with it and contaminating the area. So agriculture is our leading one, but another one is in industry. So when you have industrial factories and power plants, I don't want to say many before they made laws, but not as many now, are dumping or not dumping. Waste happens. It just happens. And sometimes it does get to the water supply system. In AP Environmental, we watched a movie called A Civil Action. And in this movie, New Jersey, I cannot remember if it was New Jersey or New York, guys, but because of the power plant contaminating the water supply, a lot of children died of cancers, developed cancers and died. A lot of adults got sick in that area. So when the companies give off their waste, where's it going to go? The third one is mining. You're thinking mining. How does that affect? Because I know it's a little bit strange. It doesn't have direct contact necessarily, but with mining, you think of how do they mine in areas? Surface mining. So surface mining or any other type of mining actually gives off those toxins, chemicals that can seep into the water supply, those sediments. Think about even with mountaintop removal, when they blow the mountaintop off to dig to get to that. Well, there's water involved in that. Not so in addition to air pollution, there's water involved in that, and water has to be moved. I'm sorry, sediment has to be moved from one place to another. Where are they going to put it? You blow off a mountain, where are you going to put stuff? You can't just leave it there. You blew it off. The sediment has to go somewhere, so that sediment can get into the water supply as well. So looking at non-point pollution, the effects and the causes. So when it reaches the bodies of water, it reaches the bodies of water through the streets and through the sewers, the sewer system that we have. It says in the PowerPoint that pesticides, fertilizers are washed off lawns. So going back to like that agriculture, for example, of how those pesticides and fertilizers run off, in agriculture, those are your bigger industries. But here it says it runs off lawns. Well, what do you mean? Well, as homeowners or property managers or businesses, pesticides and fertilizers are still used, and they're used to beautify the area that we're in. Okay, you want to beautify your house, you want to beautify the shopping mall, however that goes. So when precipitation happens, that can still run off into the streets and the sewers through the sewer system. So that still plays a part. So we can't say is agriculture is the biggest part, but as humans also, as individual humans, as families, we can have that same effect on a smaller scale. Another one is animal feces float away from farms. So yes, there's plenty of animals that are there. If it's a heavy rain or if someone doesn't get to pick up um, the animal waste, that can too run off into the streams or run away from farms. Let's put it that way. Now, 96% of water pollution is from non-point sources, which means we do not know where 96% of water pollution actually comes from. So we can only identify 4% of the sources itself. That's a pretty staggering number. So it's difficult to, it's very difficult to stop larger scale water pollution if it cannot always be identified where it came from. Now, we have talked about the water cycle and how it works and this natural recycling of water. Now, the water cycle is nature's way of recycling the water. How do we as individuals get that recycled water to us in different formats? So think about when you go to the bathroom. Okay, you go to the bathroom, flush toilet, what happens to the water? It gets recycled. Okay, it gets recycled, purified, and you eventually drink that water somewhere down the line. Or someone's drinking that water down the line. Doesn't mean exactly you. So water goes into a treatment plant after it is flushed. Okay, so it's not harmful not all harmful substances are removed when that happens. So when you flush that toilet, that water goes somewhere. It goes to that water treatment plant. But again, not all the bad stuff from your water, whether it's a bath you're taking, whether you're going to the bathroom, it is not all, it's purified, treated, but again, it doesn't remove 100% of anything. Now, I don't want you guys to stop drinking water. Keep drinking water. Okay, it's purified, but nobody gives a 100% guarantee on anything anymore. So what happens in industrial wastewater and storm runoff contains toxic substances that aren't removed. Again, 100% of things cannot be removed from the water supply. There's always going to be, even if it's 99.99% clean, there's still that 0.01% that could possibly be there and untreated at all. I want you also to think a little bit about Flint, Michigan, for example, when they decided to take their water source. Now, remember what happened in Flint. So, and it's still actually occurring. They don't have that clean drinking water, clean bathing water. Their water comes out very, we'll just say funky for the entire city. And it's been going this way for months. I want to say, well, it's been going on for over a year uh, that we've been notified about it. I think it's been actually going on a lot longer. But their water supply is contaminated, even though it goes through, it's where they get their source, and the pipes are not treated properly, is a big thing. But even water filters don't filter out everything. Nobody guarantees 100% filtration. So we have to look at that as how is our water treated, and to look into that more. So in order to look at that more, I wanted to definitely give you this visual of how the water is filtered. So we're going to watch a video, if we haven't already watched the video, on how the filtration process works. But this is a good one as far as it goes through the initial tank. So you have a screening there, and the screening takes out some of the larger particles that you have. So it goes through that, and as you can look, I want you to look at the processes that we have. And note after the setting tank and the aeration tank, remember the zone of aeration is a zone of air. Okay, so the aeration tank, air is being applied there. It goes through special lighting. It goes through a digester. It goes through UV light, and it gets a little chlorine in it. And chlorine, another word that we think about when we think about chlorine, is bleach. Okay, so it goes through this different kind of cleansing process, as you can see. Now we've talked about water has a high specific heat. Okay, so looking specifically at our water, high specific heat, which means it takes a lot of energy to cool it. It takes a lot of energy to heat it. One of the ways we describe that is look at how far the difference is between water freezing at 32 degrees Fahrenheit to water boiling at 212 degrees Fahrenheit. That large range tells us that it has that high specific heat. So total dissolved solids is a term you need to understand, or terminology. It's combined living and non-living substances that are dissolved in the water. So think about sugar dissolving. Again, we've talked about tea and hot tea and cold tea, but think about it dissolving into the water. Okay, what do these combined things have? These total dissolved solids. Agriculture is key. Okay, point source pollution and discharge from sewage treatment plants. So those are dissolved solids are in, and we've talked about the smaller particles are in water. Now, when you get to total suspended solids, that's living and non-living substances suspended in the water. And when I want to go back again to our hot tea, cold tea. So if something's total dissolved, think about it as that hot tea in the sugar. Okay. If something's suspended, I want you to think about the cold tea and how those particles we said float around. They eventually sink to the bottom, but float around. Okay, so total dissolved and they're completely suspended means that those substances are still in that water, suspended in that water. Now, moving from the the physical properties of water to the chemical properties of water, one of the things is pH. And you probably heard pH balanced. I know you've heard pH before. So getting into it at this point is not something that we will do for this lesson. In this video. But I do want you to click on, I have added in Google Classrooms a video on pH that you need to see. So that'll save us some time as we go through now. But it's the measurement of hydrogen concentration in water. A pH above 7 is basic, and a pH below 7 is going to be acidic. Now look at dissolved oxygen. It's the amount of oxygen dissolved in water. Low oxygen levels can kill ecosystems. So we need, and we're not the only ones, many of the organisms, majority of the organisms, well, plants are actually the majority when you get to it, because there's producers and we need more of those. But we take in oxygen and we breathe out carbon dioxide. And we've talked about the plants taking carbon dioxide and breathe out oxygen, but we're not the only ones that are breathing in that oxygen. There are other organisms that are breathing in oxygen as well. So when you have dissolved oxygen in the water, that is very healthy for the organisms that are there. That are there. So that's important for them for their survival and their needs being met. So if you want a healthy ecosystem, if you want to populate that ecosystem, you want more dissolved oxygen in the water for those organisms to survive. So looking at our biotic index. So what is the biotic index? It's an indicator, okay? It indicates the types of organisms present in an environment. And the measurement is used to measure water quality, mainly used to measure that water quality in a stream or a river. Now keep in mind, biotic means living. It measures from 1 to 10. And if you look at the measurements, it's normally different. Normally if we have something higher, then it's normally good. Okay, think of this like golf though. When the score is lower, it's better. So a score of 0 to 3.5 means it's excellent. There's no apparent organic pollution. Now, if the score is higher, like an 8.51 to a 10, then it's very poor and severe organic pollution is being found. The more organisms you have, the higher that it is going to be as far as the biotic index. And sometimes as far as health of an ecosystem, that becomes a good thing. The more organisms you have, it means a lot of biodiversity. However, when you look at the water quality, not so much on that end of that happening. So we have to look at the different perspectives that brings to us. So normally it's good biodiversity wise, water wise it's not. Think about a fish pond, not fish pond, fish bowl, fish tank. That's what I was trying to do. Think about a fish tank. And the more fish that you have, the quality of that water goes down. So more often you have to clean it because now there's more fish in it. So with more people using that becomes an issue. Think about your mom and the dishwasher. Okay, the more people that are eating, that's a good thing that everybody's eating healthy. But the more dishes that mom, or actually at your age, you have to clean. So think about it from that perspective. So we've done an entire investigation on river basins. So I'm gonna breeze through a little bit here. So river basin is the area that includes the streams that a river is going to feed into. Okay. Watersheds or river basins are separated from each other by areas of high elevation. Okay? So look at that river basin. That means this stream from over here, and this stream from over here, and this stream from here, all flow into that river. Okay, so there you have that river basin. And what can I explain about your watersheds? I know you guys talked about that in elementary school. Well, these river basins are separated. When they say they're separated, by elevation is one of them. Okay, we've looked at our watersheds. Geography is a separator, a natural separator of these river basins. So looking, there are 17 river basins in North Carolina. So this is the river basin map we were working on with the other week. So it does look familiar to you. 4 of them empty into the Atlantic Ocean. If you look over to it, you will see the Pascagoula. Sorry, I still have not learned to pronounce that. And White Oak is one, and that was actually from your quiz. Okay, some flowing in South Carolina. So we talked about what's above North Carolina, South Carolina. And the remaining flow westward into the Mississippi River. Okay, so west would be that tip near, I believe it is Little Tennessee. Sorry, I had to dig in there a little bit. Tennessee being one of those areas. It's important for states to reduce the amount of pollution in river because the rivers do flow to other states. So one of your river basin questions was, why is it important for the question was related to why would South Carolina sue North Carolina? Would be one of the reasons. Well, the river basin, so the pollution flows down. So if we're polluting it on our end of the river, that river basin that we share, then that pollution is going to end up somewhere. All right, guys. Well, that is the end. Again, if you have any questions, please feel free to ask them, type them in, email me, or raise your hand.